This is the final year for the flax fertility trial. It's being conducted in various locations across Saskatchewan. So far we've seen flax is responding to levels above 100 kilograms of nitrogen per hectare. We haven't seen much of a response to phosphorus yet, but it doesn't mean you shouldn't be adding phosphorus. We still need to maintain soil levels of phosphorus. And when you're going at higher levels of phosphorus, of course with flax, side banding is better because its seed is fairly sensitive to seed place phosphorus. So let's see what this year's results bring. Chris Hulzaffel with the Indian Head Agricultural Research Foundation is just finishing the final report for the flax nitrogen by phosphorus study. The study was conducted over 3 years from 2016 to 2018. This study was initiated because flax yields have been variable and have not increased over time to the same extent as other crops like wheat or canola. This study evaluates the yield response of flax across Western Canada to various rates and combinations of nitrogen and phosphorus fertilizer. The objective was to determine if the yield of flax will respond to higher nitrogen and phosphorus rates than are typically recommended or utilized in commercial production. Each trial compared 4 rates of nitrogen at 4 different base rates of phosphorus. This generated 16 different treatments, which are listed here. Nitrogen rates were 13, 50, 100, and 150 kilograms of actual nitrogen per hectare. Rates of P2O5 were 0, 20, 40, and 60 kilograms per hectare. Flax emergence was significantly reduced by increasing nitrogen rate at approximately 3/4 of the site years. At these site years, emergence decreased by 28% on average as nitrogen rates increased from 13 to 150 kilograms of nitrogen per hectare. Even though nitrogen is side-banded and not seed-placed, the nitrogen is still reducing emergence through ammonia toxicity and/or salt effects. Overall, the reduction in emergence was not of great concern, but it does mean producers should ensure seeding rates are sufficient to allow for some seedling loss if side-banding high rates of urea. In contrast, increasing rates of side-banded monoammonium phosphate did not affect flax emergence. However, past work has shown flax can be sensitive to seed-place phosphorus fertilizer. Increasing nitrogen rates led to a slight but significant delay in maturity, approximately 70% of the time. The average delay amongst the affected site years was 2.4 days, when the nitrogen rate was increased from 13 to 150 kilograms of N per hectare. This level of delay in maturity would not be of any agronomic concern under most circumstances. Increasing rate of phosphorus fertilization did not affect maturity. Flax yield increased with nitrogen fertilization in essentially all cases. However, the response was weak at 17% of the site years, where residual nitrogen was high or yields were more limited by other environmental factors. Amongst the more responsive sites, yields plateaued at approximately 100 kilograms of N per hectare, and yield increase was about 39%. At the less responsive sites, the average increase of yield was 11%, and there still was little benefit to fertilizer rates exceeding 50 kilograms of nitrogen per hectare. At 7%, when averaged across site years, the magnitude of flax yield response to P fertilizer was smaller than observed for nitrogen. However, it did appear to be reasonably consistent. The response was linear, but the slope was likely too shallow to justify rates exceeding 20 to 40 kilograms of P2O5 per hectare. Amongst individual sites, the individual responses to P ranged from nothing to nearly 40%. Here you can see the response of flax yield to increasing rates of nitrogen at various base rates of applied P2O5. You can see the yield response to nitrogen is getting better with higher base rates of phosphorus fertilizer, but the improvement is modest at best. In conclusion, while flax yield did occasionally respond to higher rates of nitrogen and phosphorus fertilizer than are typically applied, the gains associated with doing so were modest at best. When considered along with the overall site-to-site variability in yields that could not be attributed to fertility, it is unlikely that increasing fertilizer rates beyond what most producers apply will economically increase commercial flax yields in Western Canada.